So once again, we are focusing on the applications of Newton's second law, but we are going to talk a little bit of the universal law of gravitation. So let's consider this statement. It says a block A of mass 5 kg at rest on a rough horizontal table is connected to another block B of mass 10 kg by means of a light inextensible string which passes over a light frictionless pulley. A force of 120 newtons is applied vertically upwards on block B, as shown in this nice diagram. The coefficient of kinetic friction between the surface and the block A is 0.3. Ignore the effects of air friction. And the first question, I trust you can take care of it. Now, the next question says, draw a free body diagram showing all the forces acting on block B. So by now, you know that you have to draw the free body diagram for block A as well, but on your rough work section. Fine stuff. So we have to go to the whiteboard for that. So let's start with the block in question, which is block B. So the block is hanging, we can see that. Hanging means there is no normal force. So we have an applied force, which is going vertically upwards, like that. So you'll say it's F applied, right? Now we have the tension force, which is going down. We also have gravity, which is going down. Like that. Awesome. So there are only 3 forces acting on this block. Hence, the free body diagram is 3 marks. Now we shift focus. We go to block A. So this is how it looks like. Well, this one is lying on a horizontal table. So it means we have a normal force that is exerted by the table. Because there is no other vertical force, it means the normal force will be equal in magnitude to the gravitational force. But of course, they act in opposite directions. Right? So this is what you have. Now, because the block B is pulled upwards, we can only assume that the block A is moving to the left because they didn't tell us the direction of motion. Do you see that? So because block A is moving to the left, it means frictional force will be to the right. Kinetic frictional force. Of course, there is tension force, which is going to the right. So in our calculations, we have to assign direction, right? So we always choose the direction of motion as positive. In other words, anything that goes to the left is positive. Anything that goes up is positive. Fine stuff. So we are done with the second question. So what does the third one say? Now here we need to calculate the magnitude of the frictional force that is acting on block A. So remember they told us the coefficient of kinetic friction is 0.3. So here you'll simply tell us that the kinetic frictional force is equal to the coefficient of kinetic friction multiplied by the normal force. The coefficient is 0.3. What about the normal force? We said the normal force is equal in magnitude to the gravitational force. And the gravitational force, we understand, it's mass times the acceleration due to gravity. So the mass of this block is 5 kg. Acceleration due to gravity, it's always there on your table of constants. It's 9.8 meters per square second, of course. And when you press this into your calculator, you find that the kinetic frictional force will just be 14.7 newtons. Fine stuff. Then from this point, the next question says, calculate the magnitude of the tension that is acting on block B. Do you see that? So one thing you must know is that since the two blocks are connected, they have the same tension force. Now, every time you have two blocks which are connected by a string or a rope, you have to know that in order for you to find the tension, you need to start by finding the acceleration first. And the only way to do so is to use simultaneous equations. Are you fine? Because tension is unknown, acceleration is also unknown. So we have two different unknowns. So what is the idea here? We are going to apply Newton's second law to each of these blocks separately. So let's go and do that. Now let's start by considering the 10 kg block, which is block B. So we know that the net force acting on block B is equal to MA. But what is the sum of these forces? So we have the applied force, which is positive, and then we have the gravitational force, which is negative, and then we have the tension force, which is negative as well. Everything is equal to MA. Now the applied force is given to us. It's 120 newtons. The gravitational force, we say 10 times 9.8. Tension is unknown. The mass is 10A. Now, if you say 10 times 9.8, you get 98, right? And when you say 120 minus 98, you get 22. So you have 22 minus T, which is equal to 10A. So because we know that we are going to solve simultaneously, we have to generate equation 1 from this. So let's make the tension the subject of the formula by taking it to the right and taking 10A to the left. So when tension gets to the right, it becomes positive. The 22 is still on the left, it's positive, but the 10A becomes negative. This is our first equation. Then we move and go to the 5 kg block. Once again, the net force acting on this block equals MA. Now, what is the net force acting here? Well, here it's going to be the horizontal forces, not the vertical forces. So we said anything that goes to the left is positive, meaning the tension is positive. But the frictional force, it's going to be negative. And this is what you have. The tension is unknown. The frictional force we calculated above The mass is 5A. If we make the tension the subject of the formula, we just transpose the 14.7 so that it becomes positive when it gets to the right. And then we have our second equation. So since both of these equations are both equal to t, it means they're equal to each other as well. So because they're equal to each other, we might as well equate them. Like that. Then what do we do from here? Let's take 10A to the right so that it becomes positive. So 5 plus 10 will just be 15. And let's take 14.7 to the left so that it becomes negative. So when you say 22 minus 14.7, it's going to give you 7.3, like that. Then from this point, you divide both sides by 15. You find that your acceleration will be 0.48666 up until you get 7. Then you say meters per second squared. Well, it's advisable to write the full answer here so that it doesn't affect your final answer. The rounding off can affect your final answer. So now that you know the size of the acceleration, you don't need to write the direction. Just the magnitude is okay. So now that you know your acceleration, you can substitute it either into equation 1 or equation 2. You'll still get the same answer. So if you choose to substitute it into equation 2, you'll just have 5 into 0.48666666, and then you say 7. Then you say plus 14.7. So let's see how much you get. Then you find that the magnitude of the tension will just be 17.13 newtons. And then you should be happy and smiling. So that's the procedure for the tension. Both the tension and acceleration are unknown, and the two blocks are connected together. You are bound to use simultaneous equations. So you apply Newton's second law to each of the objects separately, and then you do the doables. Then you should be fine. So let's move on. Oh, so we are actually done with Newton's second law of motion. So it's time to talk about the universal law of gravitation. So let's see. They say a man on the surface of planet Y weighs half his weight compared to his weight on the surface of the Earth. The mass of planet Y is twice as much the mass of Earth. The first question says, state Newton's law of universal gravitation. Well, you can do that, I trust you. Then the last one says, calculate the radius of planet Y in terms of the radius of planet Earth. So you know these questions. You did maths, right? They can say, calculate the length of this in terms of X. So you shouldn't be intimidated by this question. Now the question is, how do we tackle this one? Now, firstly, we have to go to the relationship they told us. They said a man on the surface of this planet, he weighs half his weight compared to his weight on the surface of the earth. That's where we start. Yeah, I have to get rid of everything. At least your brain is resting while I erase here. I'm actually giving you a break. How nice is that? Fine stuff. So you have rested well enough. So this is what they told us. They said the gravitational force of this man when he's on planet Y is half the gravitational force when he's on Earth. This is what they told us. But what is the gravitational force acting on an object? Well, in this case, we are going to represent it as G times the mass of this man times the mass of the Earth. Why am I saying the mass of the Earth while I'm talking about the planet Y? It's because they said planet Y has a mass that is twice as much the mass of the Earth. Now for this one, let's use uppercase R for the radius of this planet. Now we say this is equal to half. Then for the force on the Earth, we say it's this constant times the mass of the man times the mass of the Earth. And the whole thing is divided by, let's use lowercase r. So what is the question saying? It says, calculate the radius of planet R in terms of the radius of planet Earth. Do you see that? So we just need to make R the subject of the formula. Now, this is the easiest I can say to you. If you have things that are exactly the same on both sides of the equal sign, you must know that they cancel out. But if you want to show it using formal maths, you can choose to cross multiply. So if you say GMM 2ME times 2R squared, you are just going to get 4R squared GMM ME, and then you say everything is equal to R squared GM ME. Then from this point, you divide both sides by something that you have on both sides, which is GM ME GM ME like that, so that these ones cancel out. After they cancel out, you are left with R squared, which is equal to 4R squared. Do you see that? Our aim is to make uppercase R the subject, so we introduce the square root on both sides. The square root of 4 is 2, square root of R squared, it's just going to be 2R, and then you should be fine. So for everything here, they are not going to mark you. Well, even here, because we are not doing mathematics, This is physical sciences. We mark you for the formula, for the substitution into the correct formula, as well as for your answer. Do you see that? But if you want to do things the right way, then you'll do exactly as I did. Alternatively, you have two things on both sides of the equal sign. They simply cancel out. It's the easiest you can say. Fine stuff. And this is actually the end of this nice question. So thank you so much for watching. I really hope this video helps a lot. And this paper is one of the special papers because I was writing it on my trial exam. So it was actually preparing me for the top 100. What do you know?